All right, continuing that conversation, looking at different sizes of matrix. So if I have a 4 by 6, 3, 4, 5, 6, a 4 by 6 matrix. So how many pivot columns must it have in order to be linearly independent? So I kind of established in the last example, in order to have linear independence, I need to have a pivot in every column. So let's look at what I've got here. So if I put a pivot here, and if I put a pivot here, and a pivot here, and a pivot here, wait a minute, I can't possibly get a pivot every column with this size. So can't get a pivot every column, so cannot be linearly independent. All right, so how many pivot columns must a 4 by 6 matrix, this size right here, must it have in order for its columns to span R4? So if you look at these vectors, they are elements of R4. So in order to span R4, I need to have a pivot every row. So if I'm looking to have a pivot every row, what I've drawn right here is a pivot every row. So I must have 4 pivot columns. All right. So how many pivot columns must a 6 by 5? So I'm going to encourage you to just draw X's so that you see the size of the matrix. 3, 4, 5. So there's my 6 by 5 matrix. And again, in order to span, I want a pivot. In order to span, I want a pivot every row. So let's see if that's possible. So if I put a pivot here, a pivot here, a pivot here, a pivot here, pivot here. Oh, I can't do it. I cannot have a pivot every row. So these columns do not span. Do not span R5. All right, so let's get creative and make 3 by 2 matrices. Again, get the size going. So here's a 3 by 2 matrix. So give me an example of an A and give me an example of a B. So an example of an A where AX equals 0 has a non-trivial solution. So non-trivial solution is a way of saying they're linearly dependent. So they're just asking for an example. So I'm thinking that would be an example. These two columns are dependent because they're exactly the same. I could change it and say they're multiples of each other. So that's a dependent relationship, AX equals 0, because there's a non-trivial solution. So B, X equals 0, where this only the trivial solution. So I'm thinking a pivot every column. So this would be an example. All right, so let's look at this next one. So I want the different echelon forms, so that gets us back to the stars and squares of 2 by 2 matrices, where they're linearly independent columns. So linearly independent. So remember, the squares are non-zero and the stars can be 0. So since I have to have a pivot every column, I think there is only one solution. And so if I remember, above pivots I have zeros, below pivots I have zeros. So that's the one example, or the one echelon form of the matrix with independent columns. All right, this is a different size. This is a 3 by 2. So again, make sure you get the size going in your head. So that's what it's looking like. How can I have independent columns? I want a pivot in every column. So there's a pivot, and I would have to have a pivot here, and there would have to be zeros below it. So this is the only form of a matrix that gives you independent columns of this size.